So my name is Jan Sapp. I'm a professor in the history of biology at York University in Toronto. And I write about the history and philosophy of biology. So Woese writes a book in 1967 called The Genetic Code, but it's a very unusual book because that book was embedded in evolutionary biology. It was all about how the code evolved. Molecular biologists ignored evolution. Molecular biologists weren't concerned with evolution. Molecular biology turned into primarily an engineering discipline. Right? What can we do with this stuff? It was a sort of something we had to know about the secret of life, but it itself didn't want to understand its own evolution. Thought it was off. To speculate about the origin of life was merely that, it was speculation. Let's get serious and do real science.
That was around the time I said to myself, this is biology. To study biology, you have to study evolution. And so I set up this system that could do it. This was the first system that could do it. That was the oligonucleotide cataloging.
Well, Woese wanted to do that with respect to the origins of the genetic code, to say, well, how can I study the genetic code without speculation? How can I have an empirical study of the evolution of the translation apparatus? So his answer was, well, if I can make a deep phylogeny, that is, if I can order simple microorganisms, say bacteria and eukaryotes, back to some ancient forms, perhaps I'll find organisms that have a different translation apparatus, and then I can order them in terms of the way in which the translation evolved. So he starts to do that, and he picks a molecule that is part of the ribosome. The ribosome's at the heart of the translation machinery. He thought that it was all organisms that we know have ribosomes, organisms, you know, not viruses, but all organisms that have DNA and RNA both have DNA and RNA and that can synthesize proteins have ribosomes. So here's a universal characteristic, it's an essential characteristic, just like Darwin's essential characteristic, just like Lamarck's essential characteristics. Even though Woese read neither, you know, he broadsided the field, knew nothing about, you know, classical evolutionary biology. So he begins to work on ribosomal RNAs and with the idea that if he can look at the sequences, and in those days you could have very short sequences up to about 13 nucleic acid units, right, base pairs, right? And he thought, so the first thing he did was let's see what sequences within these RNAs and these ribosomes are universal to all bacteria, for example. And so he finds patterns that all bacteria have. Finds other patterns that all eukaryotes have. The idea of molecular evolution was that it was a clock, and this was the clock that Linus Pauling and Emil Zuckerkandl published in 1965, that the genetic code, or nucleic acids, information molecules, will change like a clock, as a steady beat like that. And that is to do with just random mutations. It's neutral. Selection doesn't act on that. It's like a car with the engine going before you put it into gear, right? So, and you can have lots of variations before you actually change the protein, and evolution will only see that protein. That's the theory. So through studying the pattern of these changes in the nucleic acids, in information molecules, whether they be amino acids or nucleic acids, one is studying in part is a clock, an evolutionary clock. Woese thought that the ribosome, the RNA molecule, was the ultimate, the universal chronometer. Well, when he arrives at University of Illinois in 1964, the program of molecular phylogenetics gets up certainly by the late 60s. He has about 15 years where nobody knows really what he's doing. By 1990, everything breaks because Woese makes a formal proposal, a formal taxonomical proposal. You know, the evolutionists tolerated him before because he was sort of invisible. Okay, everybody knew there's this guy who seemed to be a little bit cranky, making all these remarks about what they take to be iconic concepts in evolutionary biology, pretending now that he can, you know, order life through one molecule, you know. And he teamed up with really, he didn't have much support in the United States. Great support in Germany, with Otto Candler and Wolfram Zillig and Karl Stadter. These were really important for this story. But in 1990, to flash forward, 1990, when they make the formal taxonomic proposal that there are 3 domains. The archaeobacteria he wants to redefine now as the archaea. And the reason he did that was that genomics, full-blown genomics, comes about. The Human Genome Project emerges by 1990. Around that time, that one could now sequence all the genes in an organism. This was amazing. This was amazing. Well, Woese and Gary Olson here at University of Illinois put out a proposal to sequence, I think it was an archaean, an archaebacteria, and they were turned down on the grounds that they already had a sequence of E. coli, you know, and one didn't need to sequence any more of these things. You've seen one, you've seen them all. I mean, that was the attitude about bacteria. They're all the same, aren't they? I mean, give me a break, you know. It was, you know, the old joke about there's 2 kinds of bacteria, E. coli and the other one, right? That was basically the view of things from the part, especially from the part of morphologists. You say, come on, these things are all the same. Don't give me. Woese wants to analyze these things in terms of molecules. So this is absurd. You can't compare the difference between a bacterium and an archaean and compare that distinction to a kangaroo and a giant sequoia. It's absurd to think that that's a distinction, you know, that would make a new domain. So Woese made 3 higher taxa, right? Proposed 3 higher taxa above the kingdoms. So his argument was there'd be 3 fundamental domains, 3 fundamental lineages of life: the eukarya, the bacteria, and the archaea. And the reason he called them the archaea was because he didn't want the word bacteria associated with them, for the reason that because people thought that all bacteria were the same, right? So it's sort of a biopolitical argument. He called them domains because he didn't want militaristic concepts in biology. You know, before we were in, you know, we were in the Middle Ages. It was all kingdoms, you know, and that's what, and we're still using these Middle Age kind of expressions, kingdoms of nature. You know, what does that mean, and why are we still living in kingdoms? I mean, you know, we're in democracies now. We don't need royalty. You know, I mean, who are these people? You know, but now we still have these noble kingdoms. Pretty bizarre, right?